So moving on to example number 6 here. This time we're trying to divide a fraction by a whole number. So something again slightly different. And my advice here would be to take the whole number and write it as that whole number over 1. Then we've kind of turned it into a fraction. 9 is the same as 9 over 1. And then we can go through the process for dividing by a fraction. The first fraction will remain as it is, but we can change our divide to multiply and then find the reciprocal of the second fraction, which basically means swapping numerator and denominator, and we've turned it into multiply. And as soon as we've got to the multiply, we can look for diagonal cancelling. They both divide by 3, leaving a 1 and a 3 behind, and then we've changed our calculation into 1/5 multiplied by 1/3. A much simpler calculation to do. Multiply the numerators, 1 times 1 on the top giving us 1, and 5 multiplied by 3 on the bottom giving us 15. So we were asking ourselves how many 9s are there in 3/5. 3/5 is very small really, it's less than 1 as it is, so there aren't going to be any 9s in it, not a whole number of 9s anyway. In fact, how many 9s go into 3/5? Well, a 15th of a 9 goes into 3/5. And there's something else that is important to mention. We've been looking at diagonal cancelling all the way. That only works when we're at the multiply stage. So when you're at the divide stage here and you think you see some diagonal cancelling, don't be tempted to diagonal cancel and multiply. Only working when we're at the multiply stage, not when we're at the divide stage.